Okay, on to page 4. On these ones here, we're going to be multiplying numbers that have exponents, and we call them powers, and as long as the base is the same, you can add or subtract the exponents depending upon whether you're multiplying or dividing. So the rule that we learned, and I'll just change to a color here, is that if you multiply, like here, you will add the exponents. Okay? And if you're doing something like here, you're dividing, so you're going to subtract the exponents. Okay, let's solve some of the questions. On the first one, both of them are going to have -2. So -2 is the same base, so that means I can add the exponents because I'm multiplying. So you write bracket -2, and you write out what you're doing. So I'm going 4 plus the second exponent. The second exponent is -2. And then you clean it up, so you get 4 minus 2, and your answer would be -2 to the power of 2. Now, you could leave your answer like that, but really you should always try to get rid of brackets if you can. Here I can, because the negative is in the brackets and the 2 is an even exponent, so you could get plus, and then you would get 2 to the power of 2. So I think that's a better answer than leaving it in the brackets. So if you can do that, that would be a better decision. Okay, on the second one, the 2's are the same, so I can add the exponents because I'm multiplying. So this one's pretty easy. You would just go 4 plus 5, and you would get 2 to the 9. Okay, the next ones. These ones are dividing, so you're just going to subtract the exponents, but I'd say this, just write out the exponent, or when you show your work, write out what you're doing, especially with subtraction. So here you would just go 5 minus 7, and you get 5 to the -2. Here you would get bracket B, 8 minus 6, because both of them are B's, and you would get bracket B to the 2, but you could also rewrite this as B to the 2. Okay, E it looks complicated, but it's not because all of them are 2m's, so that's kind of the hint that all of them can be combined. So when you have a fraction, make the tops simplified before you combine with the bottom. So here, if you had the 2m bubble or bracket, you would just add the exponents, so 2 plus 3. So the top would become 2m to the 5, and on the bottom it would just be 2m to the 4, and if you subtract these you just get left with 2m to the 1, and that's your answer. For F is a little different, and the reason why F is a little different is in all of these here, all of them have the same base. Like you had the -2, you had the 2, you had the 5, the B, and the 2m. Here, it's a little different, and the reason it's different is the m's are the same, the p's are the same, but the 3 and the 5 are not the same, and they're just written as regular numbers. So if you see questions like this, it means that you just multiply the regular numbers. 3 times 5 will be 15. And that's going to be the first part that you're going to solve. Then you would just apply the same rules for exponents. There's no exponent on the 1 or on the m, so I'm going to write a 1. And then you use the same thing. The m's are multiplying together, so go 1 plus 2. And the p's are multiplying together, so I go 4 plus 2. And then I just clean it up. I'd get 15, m3, p6, and you're done. Okay, next little section. And sorry, I've been pretty sick this week, so my throat's been starting to go, but I'll try my best here. Scientific notation. Scientific notation, I like to teach it by counting the jumps, or as we learned, butt cheeks. And goal is to try to count and move to you get a number that's between 1 and 10. So if it's 10, it's too big. So it's got to be less than 10 and 1 or greater. Here, if I did this, I would get 8.6. And then I write O as times 10. And I count how many jumps I did. So I got 1 butt cheek, 2, 3, 4. So 10 to the 4. On this one, I go 1, 2, 3. So I write 4 times 10. Now, if I wrote 3, I would have 4 times 10 to the 3. And we learned that positive exponents equal big numbers. And negative exponents equal small numbers. So right away, if I just wrote 3 here, I go, wait a minute, that's not right, because 0.004 is a tiny number. So it has to be negative 3. On this one, it would be the same thing. It would be 1, 2, 3, 4, 5. Oops, too many. Let's do that again. There we go. 1, 2, 3, 4. Because I want to stop at 8.97. Otherwise, I get 89.7. So I go 8.97 times 10 to the 1, 2, 3, 4. And it's negative 4. And then for D and F, I'm not going to do both of them. I'm just going to do the first one. If it's 5.8 times 10 to the 3, if you go 5.8, you just have to move the decimal 3 jumps because there's a 3 right here on the 10. So all you're going to do is think, if I went to the right, I would get a big number, and positive exponents are big numbers, so that's the right way to go. So I go 1, 2, 3, and where there's holes, I put zeros, and then I write it nice. 5,800. And then I look at the question. Because I had a positive exponent, I had to have a big number. So yeah, 5,800 is a big number, so I did it right. If I went the wrong way, I would know right away I didn't go the right way. Section 11. Okay, section 11. For these ones, you're going to be multiplying numbers, and you want to leave them as scientific notation. Don't turn them into real numbers or standard form numbers and then multiply. Leave them as scientific notation. So what I mean by that is multiply the regular numbers, so you get 8, then always have a power of 10, so times 10. And because these guys are multiplying, we add the exponents like usual. So you would get 8 times 10 to the 5. On this one, you're dividing, so you would get 6. Then write times 10, and count how many 10s you have left. Here we're going to go 8 minus 4, because when we divide, we subtract exponents. And you get 6 times 10 to the 4. And that's it. And I think that's it for page 4. Hopefully you watch the next part.